For months, astronomers believed that 3I, ATLAS would simply pass through our solar system like any other interstellar visitor. It was expected to sweep past Mars before disappearing forever into the darkness between the stars. At first, everything seemed routine. Then new observations began to challenge that assumption. Fresh data from the James Webb Space Telescope revealed subtle changes that immediately caught scientists' attention. The object's projected path no longer matched earlier calculations. Tiny differences in its motion raised difficult questions, and researchers started wondering whether this was behaving like an ordinary comet at all. What makes the mystery even more unsettling isn't just the possibility of a close encounter with Mars. It's the strange behavior recorded along the way. Repeating bursts of gas appeared at remarkably regular intervals, almost as though they were carefully timed. The deeper astronomers examined the data, the harder it became to explain with familiar comet physics. Instead of wandering aimlessly through space, 3I, ATLAS appeared to be making slight adjustments to its journey. Every new observation seemed to hint at a level of precision that no one expected from a natural object. Whatever this visitor is, its story may be far more complicated than anyone imagined. When astronomers first detected 3I, Atlas, it appeared to be another fast-moving object arriving from interstellar space. It was surrounded by a glowing cloud of gas and dust and racing toward the inner solar system at extraordinary speed. Its velocity alone made it remarkable, but speed wasn't what surprised researchers the most. The real mystery emerged as they continued tracking its motion. Most comets gradually change as sunlight heats their icy surfaces. They can become unstable, release uneven jets of gas, or slowly lose material. Those processes are well understood. But this object seemed different. Instead of following the random behavior expected from a comet, its motion appeared unusually organized. Small changes in its trajectory became noticeable over time. At the same time, the glowing cloud surrounding the object became brighter much faster than anticipated. Spectroscopic observations also detected unusually strong emissions associated with gases escaping from the nucleus. While outgassing is common in comets, the intensity and timing of these emissions drew attention because they didn't resemble the chaotic patterns astronomers usually observe. Then came another unexpected discovery. Sensitive instruments studying the object detected repeated bursts emerging from its tail. Rather than occurring randomly, these bursts appeared in a remarkably regular pattern, repeating at intervals of about 17 minutes. That immediately sparked debate. Could sunlight alone produce such consistent timing? Or was there another explanation hidden within the data? As observatories around the world continued monitoring the object, updated orbital calculations suggested that its projected path relative to Mars had become even closer than earlier estimates. Even a small change in velocity during repeated outgassing events could significantly influence the trajectory of an object traveling at tremendous speed through space. That possibility transformed what had seemed like a routine flyby into something much more intriguing. Some researchers began comparing the repeated gas emissions to tiny thrusters, capable of producing minute adjustments over long distances. While no one claimed this proved artificial control, the comparison illustrated how sensitive orbital mechanics can be. What concerned many observers wasn't simply the changing numbers. It was the consistency. The bursts appeared to occur in a repeating rhythm, and the direction of those emissions seemed unusually favorable for altering the object's path. Instead of merely watching another comet pass by, astronomers found themselves studying an object whose behavior refused to fit comfortably into familiar expectations. As more observations accumulated, speculation naturally grew. Among the more controversial ideas was a proposal from Harvard astrophysicist Avi Loeb, who suggested that unusual interstellar objects deserve careful examination rather than immediate dismissal. His comments reignited public debate over whether every strange observation should automatically receive a conventional explanation. Adding to the discussion were radar observations that some researchers interpreted as unusual, along with amateur images showing narrow streams of material extending away from the object. Although these observations remain subjects of debate, together they fueled growing curiosity about what 3I ATLAS might truly be. If it eventually passed Mars safely, many questions would remain unanswered. But if its path continued changing, the mystery would only deepen. One thing had become clear. This was no longer just another object crossing the solar system. It had become one of the most closely watched visitors ever discovered, and every new observation seemed to reveal another puzzle waiting to be solved. As researchers continued studying 3I Atlas, attention shifted from what the object was doing to what might happen if its course brought it dangerously close to Mars. The possibility alone was enough to spark countless simulations. Even though the exact trajectory remained uncertain, scientists knew that an object of this size and speed would release an extraordinary amount of energy if an impact ever occurred. Such a collision would do far more than carve a massive crater into the Martian surface. The shockwave could throw enormous quantities of rock and dust high above the planet, sending debris into orbit and possibly beyond. Some fragments might remain trapped around Mars for years, while others could begin long journeys through the inner solar system. The greatest concern, however, wasn't the explosion itself. Mars represents decades of scientific exploration. Orbiters circle the planet every day, mapping its terrain and atmosphere. Rovers continue searching for clues about ancient rivers, buried minerals, and the possibility that microbial life may once have existed beneath the surface. A catastrophic impact in the wrong location could erase years of research and permanently change sites scientists have been carefully studying for generations. Another question soon emerged. What if the object carried more than ordinary ice and rock? Some researchers began discussing hypothetical scenarios involving complex organic compounds. These conversations were highly speculative, but they explored the possibility that interstellar objects might transport unusual chemistry formed far beyond our solar system. If such material reached Mars, scientists wondered how it could interact with an environment that still holds many unanswered mysteries. This idea led to discussions about planetary contamination. While no evidence suggested that 3I ATLAS carried anything biological, the possibility reminded researchers why space agencies take planetary protection so seriously. Introducing unfamiliar material to another world could complicate future searches for evidence of ancient or present-day life. As the object moved closer, the James Webb Space Telescope performed another series of detailed observations. Every available instrument collected information across multiple wavelengths, searching for clues hidden within the cloud surrounding the visitor. Some reports circulating online claimed that unusual chemical signatures had been detected. According to these claims, certain molecules appeared difficult to explain using ordinary Comet models. Other rumors suggested that rare isotopic patterns had been identified during spectroscopic analysis. None of these reports provided clear proof of anything extraordinary, but they intensified public interest. Around the world, people followed every new update, hoping that the next observation would finally reveal the object's true nature. Meanwhile, several major space agencies quietly continued tracking its progress. Engineers refined orbital models while researchers compared fresh measurements with earlier observations. Every additional data point helped improve predictions, yet the object continued presenting new questions almost as quickly as old ones were answered. Then another curious development fueled even more speculation. Observers noticed that official updates became less frequent than before. Public discussions focused mainly on routine tracking information, while more detailed interpretations appeared to slow dramatically. Whether this reflected normal scientific caution or something else remained impossible to determine, but the lack of information encouraged countless theories across the internet. Among the rumors was the claim that an internal communication referred to an impact protocol. No verified evidence confirmed such a document, yet the phrase spread rapidly through online communities, becoming part of the growing mystery surrounding 3I Atlas. If such a protocol truly existed, what would it mean? Some imagined it referred to emergency planning. Others believed it could involve protecting spacecraft already operating around Mars. More imaginative theories suggested something far more extraordinary. Without verified information, however, these remained nothing more than speculation. Another fascinating idea soon appeared. A group of analysts wondered whether the object's path itself might contain hidden mathematical patterns. Instead of searching for radio transmissions, they examined the trajectory, timing, and orbital relationships, asking whether motion alone could represent information. After converting orbital measurements into numerical sequences, they looked for repeating structures. Some claimed to find mathematical relationships involving prime numbers and elemental patterns. Whether meaningful or coincidental, these observations inspired an intriguing possibility. Perhaps the object wasn't sending a traditional signal at all. Perhaps its movement through space was the message. Under this interpretation, every adjustment in its orbit, every carefully measured approach, and every gravitational interaction became part of a larger pattern waiting to be understood.